Each component in a city multisystem must have a unique address, not unlike a phone number, so that the indoor units and your outdoor units, your controllers, can all communicate with each other. Understanding the address ranges for the outdoor units, BC controllers, sub-BC controllers, indoor units, zone controllers, sub-zone controllers, and centralized controllers is very important. The first components to address when you're addressing a city multisystem is the indoor units. Because any city multisystem can have up to 50 indoor units, the indoor unit address range is 1 through 50. Setting the address on the indoor units will be accomplished by turning the rotary dials SW11 and SW12 to their respective numbers. SW11 will be the 1's position, and SW12 will be the 10's position. For instance, if your indoor unit address was 26, SW11 would be set at 6, SW12 would be set at 2. It will be printed on the board whether it's the 1's or the 10's position. You should not assume the one on the left is 10's and the one on the right is 1's. They may be mounted inversely. Make sure you look at the board to get those numbers correct. If you can't see the 1's and the 10's marking on the board, the lower number of the 2 is always the 1's and the higher number of the 2 is always the 10's. SW14 tells the system which port you are attached to on the BC controller. You will see the numbers 0 through 9 and the letters A through F. Those represent the port number of the BC controller. 1 through 9, of course, is 1 through 9. A will be 10, B 11, C 12, and so on. Because 2 numbers would not fit under the opening in the dial, we have chosen the letters A through F. Setting 0 would be port 16. The largest BC controller that's available is a 16 port. So all of the indoor units will have settings for ports 1 through 16. It's important that the port assignment be set correctly so that the refrigerant can flow to the correct indoor unit when it's needed. When the indoor unit calls for heating or cooling, BC controller opens up that port that is set on SW14 to send refrigerant to that indoor unit. If that number is incorrect, it would send refrigerant to another indoor unit. The next component you would address would be the outdoor unit. The outdoor unit should be addressed the same as the lowest addressed indoor unit connected to that system, plus 50. So the address range of the outdoor units is 51 through 100. The main BC controller should be addressed 1 number higher than the outdoor unit it's connected to. The ME controllers have 2 rotary switches to set. They are marked the 10's and the 1's position. The number 100 is pre-programmed in the logic of the controller. The ME controller will be addressed the same as the indoor unit you're wanting to control. Address ranges for the ME controller are 101 through 150. If there is a sub-ME controller on the system, meaning 2 controllers in the same zone, wanting to control from each end of a room, for instance, the settings of the sub-ME controller would be 50 higher than the unit you're wanting to control. Address range of the sub-ME controller is 151 through 200. MA controllers do not have an address setting since they are not part of the MNet. Sub-BC controller address will always be 50 higher than the lowest indoor unit address connected to them. Address range of the sub-BC controller, 53 through 100. Whichever centralized controller you are using will come out of the box at address 000. If you only have 1 controller on the system, then you do not have to change that number. However, if you're using multiple centralized controllers in a system, then you would want to change that number since we cannot have duplicate addresses anywhere. Address range for the centralized controller would be 201 through 250. Addressing the system correctly will minimize the possibility of having duplicate addresses in a system. Let's start off with a small S-series system. The first component that we address is always the indoor unit. Address ranges for the indoor unit 1 through 50. So we'll start with address 1. The outdoor unit is the next component we would address. It will be 50 higher than the lowest addressed indoor unit connected to it, so that makes the outdoor unit 51. The centralized controller on a small system will always be left at 0. Now let's address a small R2 series. First component that we address, again, will always be the indoor units. So our addresses for the indoor units are 1, 2, and 3. That makes our outdoor unit, the next component we address, 50 higher than the lowest address connected to it, or 51. And then the branch circuit controller is always 1 higher than the outdoor unit it's connected to, so that would be 52. Now let's look at a twinned R2 system. In this case, we'll address the indoor units 12, 15, and 17. That would make our outdoor units address 62 and 63. When we have twinned outdoor units, the addresses will be sequential. The next component is the branch circuit controller, 1 higher than the outdoor unit it's connected to, or 64. Now let's move to a little larger R2 system. In this case, we have twinned outdoor units, a main BC controller, a sub-BC controller, and 5 indoor units. We'll always start our addressing on the indoor units connected to the main BC controller first. Remember, indoor unit address ranges 1 through 50. So let's start with addresses 1, 2, and 3 on the indoor units. Now we will go to our outdoor units. The main outdoor unit would be 51. The sub-outdoor unit would be a sequential address 52. And the main BC controller would be 1 higher than the outdoor unit it's connected to, or 53. Let's say this system is in a retail environment. We're going to leave an address gap between the main BC and the sub-BC for future expansion of units that would be attached to the main BC controller. In this case, we're going to address the units connected to the sub-BC as 9 and 10. That would make the address of the sub-BC 50 higher than the lowest addressed indoor unit connected to it, or 59. The only difference between the R2 series and the Y and the S series would be that there is no BC controller on a Y or S series. All the other rules would still be in place. Now that we understand unit addressing, let's add in the ME controllers and the port assignments. As we can see in this diagram, we have twinned outdoor units, a main branch circuit controller, a sub-BC controller, and 8 indoor units. Always start addressing the indoor units connected to the main BC controller first. Let's address those units as 1, 2, 3, 4, and 5. We will leave 6 and 7 for possible future expansion. So now that we know what the lowest addressed indoor unit is, let's do the outdoor units as address 51, 52, and the main BC controller would be 53. Since we left indoor unit addresses 6 and 7 for possible future expansion, let's address the units connected to the sub-BC controller as 8, 9, and 10. That would make our sub-BC address 50 higher than the lowest addressed indoor unit connected to it, or 58. Since ME controllers are connected to the network, they control by address, so they must be addressed. The ME controller should be addressed the same as the indoor unit that you're wanting to control. The 100 is pre-programmed in the logic of the controller. So if you're wanting to control address 01, you would set the ME controller at 01. It would be seen in the system as 101 to identify itself as an ME controller. Since ME controller is controlled by address, they look up the daisy chain and they will control every indoor unit up to a maximum of 16 until it sees another ME controller, and then it will stop. In this case, address 102 is controlling indoor unit number 2 and 3, and it will stop when it gets to address 4 because it sees that 104 is connected. And then, of course, 105 is controlling unit number 5. 108 is controlling indoor unit number 8, and 109 is controlling indoor units 9 and 10. Now that we have the system addressed, let's set our port assignments. If you follow the line from indoor unit 1 to the BC controller, you would see that it is attached to port 1. So we set the SW14 dial to port 1, so that when indoor unit 1 is calling for heating or cooling, it opens the BC controller port 1 to allow refrigerant to flow. Indoor unit number 2 is attached to port 2. Indoor unit number 3 is attached to port 3, so we set SW14 at 3. Indoor unit number 4 is attached to ports 4 and 5. There is a twinning kit. Each BC controller port will give a maximum of 54,000 BTUs. If the indoor unit you're using is larger than 54,000 BTUs, it must be connected to 2 ports. When you're connected to 2 ports, you set the port setting to the lower of the 2. In this case, when the BC controller opens port 4, it knows that it needs to also open port 5 because the indoor unit that's calling is a 72,000 BTU. Indoor unit number 5 is attached to port 6. On the sub-BC controller, you see that unit addressed 8 is connected to port 1. Even though there's a port 1 on the main BC, this one knows that unit number 8 wants to open port 1 of the sub-BC because the sub-BC is addressed 58. So the system knows that indoor unit 8 or above is connected to the sub-BC. Unit 9 is connected to port 2. Unit 10 is connected to port 3. If you were to address these incorrectly, for instance, let's say that indoor unit 1, we had set the port assignment to 2, and indoor unit 2, we set the port assignment to 1. So when indoor unit 1 is calling for heating or cooling, it's sending refrigerant to indoor unit 2. When indoor unit 2 is calling for heating or cooling, it's sending refrigerant to indoor unit 1. Therefore, neither of them would be able to be controlled correctly.